Hi everyone, this video is a part of Macquarie University's coding tutorials, and today we'll be talking about simple function definitions and function calls. In the last video, we took a look at function design, talking about the three aspects of a function, which is the function name, parameters, and return type. Now we move from function design to function implementation, and the syntax of the function, once you identify these three aspects, is very simple. You have to specify return type, followed by the function name, and the parameters in round brackets. In the curly brackets, you have your function body with an effectively unconditional return statement if required. I'll explain this part in a little bit. For the time being, you can just think of it as function body. We'll take the example of the function we used in the previous video, which is positive. We saw that the parameter is of type float because you can check if any floating point number is positive or not. And the return type is Boolean based on whether it is or it is not positive. Let's plug the return type Boolean in there, followed by the function name, which is positive, and in round brackets, the parameters, which is float. Now, as we saw in the previous video, the function can be called by many clients, many times, several times, over and over, and they can pass various values to the function. They can pass 1.618, negative 5.6, 0, 8, whatever they want. Whatever value is passed to the function at a given point of time can be stored in a variable, and we give it a name. So whatever value is passed, the function in that execution will call it as val. That's my example. You can give it any name. You can give it N, you can give it Tom, you can give it Hallelujah. It doesn't matter. Well, it matters in terms of readability, but you get the picture. So you give it a nice name that indicates its purpose, and in the curly brackets is your function body. How do you check if a number is positive? You check if it is greater than 0. If it is greater than 0, you want to tell the client or the caller that yes, it is positive. How do we indicate yes in programming? True. This giving of answer from the function to the client is done using the return statement. So the value we are returning to the caller is true. Very, very rarely will functions print a value. So we don't print values, we return values. So if val is 0, it will return true. Else, in all other cases, which is val less than or equal to 0, it will return false. And we close the function body. Now, when we did conditions, we know that if and else are mutually exclusive, exactly one of the conditional codes will execute, either return true or return false. But exactly one will execute, which means if I put this into code to flow, it draws the flow chart, and you can see based on val more than 0, if it is true, it will return true. If it is false, it will return false. So I get a return value unconditionally, and that's what I meant by effectively unconditional return value. Now note here, if I say if val is less than equal to 0, your control flow is fine, but if I put the same thing in my code, if val is less than equal to 0, you will see that my function has a red line, and it says this method must return a result of type Boolean. This is because for processing, there are two independent if conditions. And for processing, not mathematically speaking, but for processing as a program, as a code, it is possible that neither of them execute. And it is programmatically possible to reach here. Not mathematically, of course. And that's why it complains, because now the function is breaking its contract. The function has guaranteed it's going to return a value. which it is not. In this example, I can leave a placeholder, which is true, which we know will never reach because mathematically it will never reach. But this is not good programming practice. You should use if else in this case because there are two paths which should be mutually exclusive. Okay, so that is our function design, and that is our function. Now, how do we call the function? Once we design a function, you can call it from wherever you want, including setup, or draw, or mouse press, or key pressed. So let's just put empty setup and draw, and calling the function. You call the function by calling its name is positive, and passing it a value. Now what we're doing is we are checking if the function, we are calling the function with the value 5, but the value that it returns back to you, which is either true or false, you're ignoring. So when I run the program, it will do nothing. It will call the function, but it will terminate immediately. Now, Java and processing allow you to do that. They allow you to call the function, but ignore the returned value, which I don't personally like, but I'm sure they have some reason for that. Because these people are very, very clever. So what I want to do is, when a function returns a value, typically speaking, I store it in a variable. So I'll call it answer5. Now you can see that there's a gray line under the variable because I haven't used it. So I can now display is 5 positive? And the answer is answer 5. Let's run this. And you can see that is 5 positive returns true. Let's create two more variables, answer this and this. So we're going to have 0. We're going to pass the value 0. And we'll have answer 1.618. 1.618. Let's call it negative. Answer negative 1.618. Negative 1.61. Oh, what am I doing? 618. There you go. Answer 5 will return true. Answer 0 will be false. Answer neg 1618 will be false as well. Let's run this. And those are my three answers. Only 5 is positive out of the 3. We did take a look at the debugger earlier, so that's what we're going to do to actually see my function is executing. So I'm going to enter the debugging mode and place breakpoints throughout my function and also throughout my setup. Now I'm going to enter the debugging mode and it will enter line number 9, 10, 11. So when I run the program in debugging mode, it's line number 11 that executes. No variable has been created yet. I give it a permission to execute line 11 by clicking the continue button. And you can see that the control has transferred to line number 2. And the value of val is 5.0. You can see that the parameter that was passed was 5, and we say that 5 is the actual parameter. And over here we say val is the formal parameter. So this time the function is being called with value 5.0. Even though we pass 5, it's being casted to float. So effectively what happens behind the scenes is float val becomes value passed. That's what happens. So val becomes 5.0. It executes line number 3 because val greater than 0 evaluates to true. So the if block executes, it returns true to the caller, which is line number 11, which means is positive 5, the function call, is replaced by the value true, and therefore answer 5 becomes true. Now we've come back to the scope of setup, and therefore you can see that val has disappeared from your variables because that function's execution is over. It will display answer 5 and go to line number 14. This time it calls is positive with the value 0. Val will become 0.0 and the control will transfer to line number 1. And you can see val has become 0.0. It evaluates the expression on line number 2. Is 0.0 greater than 0? No, it's not. So it enters the else block and returns false, which replaces the function call is positive 0. Therefore, answer 0 becomes false. There it is, and you display it. Third time you call the same function again, this time with the actual parameter negative 1.618. That value is copied into the formal parameter val and control is transferred. You can see val is negative 1.618. And is the Boolean expression for the condition true? No, it's not. Negative 1.618 is not more than 0, so it enters the else block, returns false. This false is returned back and replaces the function call, and therefore your variable ans neg 1618 becomes false. It's displayed on the screen. We call the exit statement to close your program, and your program then terminates. So hopefully this example helped you. Let's take one more quick example before we finish. Let's create a new program for this. And let's say the function I want to create is to check the highest of 3 integers. So I have 3 integers, and the formal parameter names I'm going to choose are A, B, and C. If the 3 values are integers, their highest is one of the 3, which is also an integer. Therefore, my return type is integer as well. I can now check if A is at least as big as both B and C. It means that A is at least as big as B and also at least as big as C, and therefore my answer is A. If we reach line number 5, it means it's guaranteed that the answer is not A, and that's a beautiful conclusion to reach, because now it means that you can completely disregard A as if it never existed. Now I only need to compare between B and C. So I can just check if B is more than equal to C. And if that's the case, between B and C, B is the highest. If you reach line number 9, it's guaranteed that answer is not B either, which means unconditionally you return the answer C. Please note that if you put that return C in a condition, again, we'll have the same problem that the function must return a value. This time, I'm not going to do anything inside setup. I'm not going to do anything inside draw, but inside key pressed, I'm going to generate 3 random numbers. Int x is a random integer between 0 and 100. Same y and z. So 3 random integers. And int max is highest between x, y, and z. And display highest between x, y, z is max. Let's run this program. And obviously nothing will happen until I press a key. So whenever I press a key, 83, 17, 82 is 83, 46, 25, 24 is 46, 52, 75, 16 is 75, and so on and so forth. If you really want to see how your program is behaving, you can place a breakpoint. You can enter the debugging mode, place a breakpoint on line number 23, 24, and on lines 2, 3, 5, 6, and 10. Run the program to enter the debugging mode, which will keep running it until you press a key, which is when it will go to line 23. X, Y, Z are 93, 30, and 28. These are the actual parameters we are passing. X is copied into A becomes 93, Y is copied into B becomes 30, and Z is copied into C becomes 28. Let's confirm this by resuming, and you can see it is true. The first condition's expression is actually true because 93 is more than equal to both of the other variables values. So line number 3 executes. The value of A, which is 93, is returned and copied into the variable max, and it displays that the highest between 93, 30, and 28 is 93. That's it for this video. I hope you benefited from this video, and keep programming, keep practicing, and I'll see you soon.